with the third part, one of the most important modules of hybrid GEOTABS concept, that is tabs. And I start with a little bit introduction of myself and my company. So as Lieve introduced, I'm working as an innovation and research specialist in Uponor. And I think some of you have already known the company. And I start to introduce a little bit of what I will talk about to give you the information today. So introduction of tabs and how it works in general. Then the construction of tabs. So continue with installation and how we usually do the optimal design from industry experiences. So this is a combination of theoretical work with quite practical information to give you if you're interested in tabs, and a little bit more cost perspectives of tabs based on our previous projects, and some special application of tabs. So, Uponor, shortly an introduction of my company. Uponor is a global company, as you know, working with heating and cooling and piping system and plumbing system, also for the infrastructures. We cover a large part of the world, mostly Europe, East Asia, and North America. We have around 4,000 employees all over the world. Then, when it comes to HVAC or building-related components, we produce radiant heating and cooling solutions, such as floor heating, and also tabs, of course, and cooling panels, and also related fittings and manifolds and boards to connect the systems with, for example, heat pumps and district heating pipes. So, and partly also the ventilation vents for air handling units. So, we come to the main content today for the tabs. When we're talking about tabs, we usually refer to low temperature heating and high temperature cooling system. So in general, when we're talking about low temperature heating and high temperature cooling, we have three systems. So the first one, if you see from the left part, it's one of the most classical ones. The systems are embedded on the surface of the system. For example, floor, wall heating, and ceiling heating, something like this. And the second type, if you see to the right one, it's called radiant cooling panels. So it's a suspended system below the ceilings usually, so it's not integrated in the structure of the building. And the last one is the one we're going to talk about. It's tabs. So you can see the structure of the tabs. The pipes are embedded in the middle of the concrete, so the whole building as a structure is heated or cooled by the system. Yeah. Then, before I continue, I want to have some questions to discuss with you. So, how many of you here have heard about tabs or being familiar with tabs? Yes, quite many? More than 70%. Okay. Then, following this question, I want to let you to guess or give a shot. When do you think was the first tabs appeared?
The Romeinen.
The Romeinen? Any more questions or answers? Yes?
Some years ago.
Some years Because when we're talking about tabs with our students or engineers, usually people think it's a rather modern solution or new solutions in construction business. So actually, I put some history of tabs here. So this is not a new technology actually. It's from different part of the world. So if you see the first one is from actually the northeast part of Asia, in both northeast China and Korea. So there is such a word even for it. So the idea is that a large area of your apartment, 1/3 is being heated, and people sitting on the bed during the day when you heat it during night. And the other one, you're right, and from the Roman time, and actually we found a lot of sites. So this is from 350 BC. We found that you see this hose here, so the hot air is going around below the floor, and also you can see it through the walls. So 7,000 years ago, basically, we have already started to use tabs. Okay. Now continue with the modern times of tabs, how it's introduced. So it's very interesting to see that when we're talking about tabs, I think 99% of the people here, we are engineers. But actually the idea of modern tabs were introduced by architects. So, because we think in different ways. The architect, Frank, he's an American guy, and he claimed several times he didn't like the pipes, and he's very fascinated to use space more efficiently. So he first tried to use the pipes in his house in 1930s, and it worked. Then followed his idea, because taps you really don't see the like this pipes and vents very much because it's somehow covered in the structure. Yeah, but this is the whole concept of taps. So the modern times, taps has been evolved and being introduced, mostly the change to use water. Okay? And this is being used by a Swiss researcher, introduced in 1993. This is the first actual taps being constructed. So we have circulating water around the pipes instead of the hot pairs. So a little bit history for the taps. Now we're coming to the real thing. So here is a picture that how taps looks like in details. So I have to mention that taps are usually primarily used for cooling purpose and also used as a basis for the heating. So we don't really use taps for everything of the heating or everything of the cooling. We always need a system that, for example, ventilation, because you need to keep good indoor air quality. So taps provide sensible cooling and secondary for base heating. So this is very important for you to know how to use taps. Okay? Then a little bit more practical information how taps works or how you should understand the taps. So for example, we have mild temperature in Europe, but also we have very warm temperature in Mediterranean countries and very cold temperature, climates in Scandinavian countries. So when it comes to not mild, always very hot or very cold climate, we always need a supplementary system, or we call it secondary system, in order to compensate to the taps. So taps and the secondary system or supplementary system. This is how you usually start with the design. Yeah? And we need to be careful that sometimes when we use ventilation system, we need to consider the humidification levels, because taps don't provide any ventilation. Okay? A little bit more information on how taps works. So if we compare this, if you see the figure here, this is the outdoor temperature, the dashed line, and the yellow line here is the office without cooling. So of course, as you expect, the temperature will go as the ambient temperature. And if you see the red line here, this is the temperature when you have taps. So the main effect you can see is the tap make the temperature much flatter than other system, and also it shaves the peaks. Okay? And why this happens? This is because we charge water all over the place around the building. Then the building has a much larger thermal mass. So it has strong resistance to the ambient temperature change. In another word, the storage effect is there. So we can see this is a storage effect during different time of the day. Okay? And be careful that we here say office wing. This is a reason that I will introduce a little bit more how we use taps in different parts of the building. So office wing, that means that the places you are very much exposed to the sun, for example, and outdoor environment. Okay? Okay, a few things for you to know how taps works. As we mentioned, taps are primarily used as cooling, usually in offices, not in residential buildings. And if we compare these three systems, so the first one is without any cooling or no solutions, it gets very hot when the temperature outside gets warmer, of course. Then the second one is that we have some kind of AC system, air conditioning system. We have the convectors here. Of course, you need certain heights to put the vents there. Yet sometimes people suffer a little bit problem with the draft or cold effect. You don't feel that much local comfort. So the third one is a taps. So the benefit here is that we really save the space, for example. We don't need to use that much vent. And something we need to be careful is that how we operate taps or how we use taps. So it's always important to keep in mind that when we use taps, we don't set an exact temperature like 20 degrees all the time. We let the temperature drift a little bit, but within the comfort bounds. This is the best way of using taps. So this sometimes happens when engineers design they set a very strict operative temperature, for example, then this is not the best way of using taps. You should let the operating temperature drift a little bit to have certain bound. Okay? A little bit the integration of taps with other systems. You have known the ground part and also the heat pump system. So taps are very much often used with the heat pump system. We have supply and temperature for both heating and cooling that is very close to the room temperature. For example, 16 to 20 degrees for cooling and 20 to 28 degrees for heating. It depends on the load, of course, and the case. And this is a typical low temperature heating and high temperature cooling system. With low exergy, of course, you can use a lot of renewable sources. Depends on the availability of the sources. So, some more information about taps. So, there are basically 4 types of taps. Of course, it's a quite straightforward principle when we have taps, because you have pipes in the concrete. Okay? But in practice, there are different types. The first one is the most common one we're talking about, the standard taps. So you have the concrete and you have pipes in the middle of in the core of the concrete. We will introduce a little bit more here afterwards. Then we have the second type, is taps with the thermosocket type. So in this way, we split the water circulates to the taps into other supplementary systems, for example, cooling tunnels. And the third one is the surface near taps. You can see that the pipes are closer to the surface of the concrete. So this is a little bit similar to the wet system of like floor heating or something. Then, of course, more high performance surface near pipes, which means that you have more intensity of the pipes. There are more pipes into the surface. Okay, I will introduce a little bit more information based on different types of the taps. So when we come to the first one, the standard taps, this is the standard taps, and we have different types, subtypes of the standard ones. So this is the most common one that we have just concrete. Okay? And we have concrete, you may have carpets on top of it, and this is a concrete, and with 4.3 meters. So it's very important when it comes to the design to understand what will be the heat output of the taps. So you can integrate into the right system or choose the correct secondary system in order to compensate. Okay? So when we have this return and supply temperature, we did the FEM to analyze the heat transfer and the cooling and heating capacity of the taps. So, and this is validated in our German lab. So the first one, if you see the cooling mode, so you have around 57 watts per square meter for the cooling mode and around 40 watts per square meter for the heating mode. Yep. And of course, you will get heat and cooling from both above and below. Yep. So the second type of the standard type is taps with step-some insulation layers. Why this is a second type? Because in most of the offices, you have smaller office rooms, big office rooms. And when it comes to taps, you need to think about the echo effect. So you don't, when you have a small room like where we are sitting now, you don't want people, when they talk, you hear too much of the echo. So sometimes people put, you can see here, there is insulation for the sound, very thin layers. And of course, this will reduce a little bit the cooling and heating capacity. This comes to around 47 watts per square meter for the cooling and 29 watts per square meter for the heating. Yes? And the second one, this one is very common actually in Germany and also in some Scandinavian countries. There are raised floors. So the floor is a little bit above the concrete of your floor. Here also, of course, we have a little bit reduction of the cooling and heating capacity, So around 47 and 29 for cooling and heating, and this is similar to the previous one for the capacity. So it depends on which kind of floor structure you want and the situation you have when it comes to the building properties. Okay. Now we introduce a little bit the near surface of the taps, that type. So as we introduced, it's a little bit similar to the concept of the wet system. Okay. So but the pipes are still embedded in the concrete and it's constructed together with the building. So this is still a tap. Okay. So you can see this is how it looks like. You have the steel mesh and you have the pipes on top of it. So it's the same procedure as regular taps. But of course, the heating and cooling capacity will be different. So here you can see this is a comparison of the surface near taps, okay, with standard taps and surface near high performance taps. So the red one here is for the heating and the blue one for the cooling. So you see the differences of heating and cooling. And be careful that maybe you will say, oh, the high performance one is always having a higher capacity for heating and cooling, should we all use this one? No, answer is of course no. There is a philosophy of optimization, how we should combine these two into a real case. Because when you have high performance system, of course you lose the effect of charging and the storage. You don't heat or cool the concrete that well as the one in the core. Okay? So this is the second main type of the taps. And be careful here is that this is a maximum heating and cooling capacity. So the average will not be like this. So the last type of taps, we have the thermal socket taps. So how it works. So if you see here, this is a taps, and we have a thermal socket. It's like your internet. You plug it, and then it can be, for instance, in this case, connected with a cooling panel. So this is suspended below the taps, and the connection is quite simple with pipes. In this way, you can have supplementary measures for cooling with taps to use additional heating or cooling system. And of course, basically you are cooling the room with two systems, taps and the cooling panels. Then you can increase the cooling capacity to 150 something watts square meter, so it has been larger increase. But this is depending on the situation, where the peak happens during your building and how you want your cooling system to be designed and operated. Okay? And I will introduce a little bit more installation later on after this, how this installation should be done in practice. So I think maybe it's interesting for you to know a little bit more practical information, because a lot of you are researchers. Maybe you never worked on site with a tap. So it's good to know that how the things you're working with is actually done in reality, right? So the construction of the taps, in a way, is straightforward, but in a way, it's not that straightforward. So you always need the mesh, of course. Then the main component is the pipes, of course, and you need different fittings and connections and staplers in order to make the pipe in place so it doesn't go around in the place. And there's some pictures of the construction site. But later on I will show you a video how it's done by our engineers and installers. So basically you see we don't do the pipes on site. We always deliver the pipe package in the pack. Then we place it on site. Okay? Then it's very, very important in practice you test the pressure drop of the taps. Because if leakage happens, there will be a huge problem afterwards. You will have a ring in your room or wet floors, and it's very, very hard to fix. So it's very important we do it well and perfect from the beginning, and tell the people that you should not put a huge lamp here, because if you drill it, then you take a shower after. So it's very important to do this and teach the people, the construction people, that you should do according to the guidance, and then do a pressure test to make sure there's no leakage during the whole circulation of the pipes. Then you press it to make it tight. Okay? How it looks like. So yes, so you can see that we have the distribution pipes, main pipes, and this is based on different zones. We will discuss about this later on. And then we put the concrete, we pour it, and you fill up all the concrete on top of it. Yeah. Then of course we have ceilings and floors. If you have slabs, you can just directly put on top of it. And the new concept is that because this may take time to pour the concrete and do all the constructions on site, so we also have another type which is more modularized. So you have the slab already and the pipes are in it. So what you need to do is directly put the slab with the pipe on it, then connect the slab. So this is more lean construction. Yeah? So this is how it looks like. I took this picture a long time ago from Germany, and this is exactly the moment when you're done with the taps. You see all these connections, and they should be connected to the manifold that you have designed. Yeah, a little bit more information how it looks like after you have done some decorations and arrangement. So this is the one in UK. This is for classroom, and also for another one in China. This is another, the one in China is a lab, and the last one is in Spain. It's a office space. So we have different types of buildings to use it. So following up this, I would like to share a video with you to also make you awake to see how it's animation, how the time changes, the basic principle of taps, and how people work on the taps. Okay? Now we continue with the presentation. So I guess you get a little bit familiar with how taps are actually constructed on site. And during the commissioning of taps, it's worth to mention that the good communication with architects is always very important. So if you see these reference buildings shown in the video, so usually in taps office buildings we have a lot of windows, a lot of glazing areas. So there are three key things are very important when it comes to the optimal design of the taps. The first one, of course, is the load. You need to understand the load and don't oversizing the zooms of the taps. The second one is, of course, this is related with the architects. So how actually this building is designed. For example, building with a lot of wing areas, and these wings are highly exposed to the solar radiation because taps are very, very sensitive to the sun. So when you have solar radiation a lot in certain area of your taps, you need to consider the geometry, for example, and how this should be done or designed or modified with the architects. Then the last one is how the building is used for office, for example. You have certain areas with a very, very high occupancy or meeting rooms that all of a sudden you have a very high peak load in a short time. Then you need to design a supplementary system properly in order to avoid this thermal comfort like what we are having now. Okay? So in general, well, if you remember there's different types of taps, their principle is the same, but the good combination is the philosophy of optimization. Because, for example, if certain areas along the windows or certain area that is highly exposed to the solar radiation, it's always better to choose high-performance taps than connected with ordinary taps. And so far, we haven't achieved, it's a pity that we haven't achieved a standard or industrialized method in which situation we should combine what kind of taps together or with secondary system. So this is something also we want to achieve through our project. Okay? So a little bit integration or installations of taps with the hydraulic system. So the left one is a standard integration of taps, that's through pipe system. So the socket integrated into the tap water, so it doesn't split. And the third one, the second one is a 4-pipe system. So the socket actually separate the circuits into a supplementary system, for example, cooling panels, and in order to cover the peak load and with faster thermal response time. Yeah. So I think you have learned quite a lot from Peter about the heat pumps. So here is just a follow-up that the taps can work with basically all of the mode of the heat pumps. For example, heating and active cooling, and also both heating and cooling at the same time, and passive cooling, which means that you just circulate the cooled water from the ground. Yeah. And the classical combination of taps is with heat pumps or ground source heat pump. Because, we can see here is a hydraulic scheme of the taps and secondary system. And be careful here, if you maybe you're not very familiar with what is this. And this is usually, we call it manifolds or ports. And they are very, very important to be correctly designed. Because you don't want to put manifolds everywhere, in all of the room, because it's kind of big. You don't want to use too many manifolds. So when you come to the design of the taps, how you design the manifolds are also kind of important, because if you have one zone, and maybe you don't want to have 3 or 4 manifolds to combine different zones. Usually you do it with one zone, one manifold for all the taps. But sometimes this side is highly exposed to the sun, this side is always in the shadow, but you cannot provide different temperature or flow rate because you have one manifold connected. Okay, so it's important to keep in mind this practical information. You need to size the manifold and put it in the correct place. Then manifolds here are connected with risers because it's hard to find an office that is only one floor. Usually you have 10 floors, 12 floors, and one risers can have different branches like a tree connecting different manifolds. But risers, you also don't want to have too many risers because, for example, you have too many risers, you need space. So we always need to consider the demand from an architect. So risers should be also optimized in order to have the correct numbers of risers and connect to the correct zone of the taps. Okay? Then we have ground source heat pump and the ground collectors. And the second issue we need to always consider is integration of the taps with the secondary system. Okay, how this should be connected. I think Pieter showed the picture before. Usually you use mixed valves. So you give the same water, that if it's needed for the peak load or secondary system, you lift it up. Or you have two separate systems. The supply temperature is always the same to the taps, but you can vary to the secondary system. But then, when you have a complicated system, the control comes to your mind. Because if you don't control it, it will become like a baby, and you never know how it will react. So even we always, as engineers, simple is beautiful. But sometimes, if you want to have some kind of system that's more than two, you need to control it in a proper way. Yeah? Lieve will introduce a little bit more afterwards. So a little bit more example. This is, for example, not only ground source heat pump. We can also use very much with solar, because this is also low temperature heating, and you can have absorption heat pump. So this is just another example how you can connect the taps with the energy supply system. So we don't have too much time, but I still want to raise another question about the cost. So if you have seen the construction of the taps, do you think it's expensive? Any questions or answers? No. Yeah. In a way, yes. In a way, no. It depends on it depends on how you design it correctly. So here we did a study actually in 2015 comparing 5 countries: UK, Germany, France, Spain, and Russia. And because these are all real cases, and we used a market price for all the components, and we compared tap system with the boilers, for example, the first one, so without a ground source heat pump, and the second one, taps with ground source heat pump, and 3 other common solutions for heating and cooling in office buildings, for example, FCU, fan coil units, displacement ventilation, if you're familiar with displacement, so it goes like this, and then chill heat. And all these 3 are connected with boiler as a heating and chiller as a cooling, but instead taps working with ground source heat pump and passive cooling. So this is basically the concept of the comparison to see how exactly taps with hybrid GEOTABS can provide cost benefits, because this is very important for all the stakeholders if you want to use a tap in your future design. Okay? And short boundary condition what we use. So in order to have a fair comparison of different systems, we provide the same indoor air quality and use the same control algorithm for the fan coil units and beam and displacement ventilation. And the result I will show you is based on the case in London. Okay. So this is a light of all the components that we studied, and a lot of people ask how long is the taps. I would say that it can last forever, because as long as your building is there, then tap is there. If you don't have the building, then you don't have the tap. So taps will be the same lifespan of a building. Okay? Yeah. So we split the cost into 3 parts. The first one is the initial cost, because this is very important for the construction companies and building owners to know how much you need to pay for the investment. So you can see here, the second one is taps with ground source heat pumps. And here, the green one shows not only the initial cost of the taps, but also the boreholes we need to drill. So we can see that actually taps are not very costly at all if you don't have the drilling for the boreholes. Okay? And a large part actually is because this one don't have ground source heat pump, this one has. So actually a lot of money comes from the ground part. Okay? So the investment cost for taps with ground source heat pump is rather high, you can see, but you know where the cost comes from. Okay? And if you only use taps, connect with boilers or chillers, the initial cost is not expensive at all. Okay? Then if we continue with the operational energy cost as we expected, of course, taps with ground source heat pump has the lowest one. And be careful here, the result shows only 15 years. Okay? Okay, this only shows 15 years. So if it's 50 years, it will be different. So this is only 15 years of operational energy cost. And already in 15 years, we can see taps with ground source heat pump as the lowest one. Okay. Then the last one is life cycle cost. Even though life cycle cost, you can have a lot of assumptions and stuff for maintenance and things, but still we try to use as much as real case in a commercial project to get a good price data in order to have a good study. So you can see that taps with ground source heat pump is somewhere here. It will cost around less 70 euros per square meters heated floor area. And then if we compare this with other common solutions like fan coil units, it's still cheaper. And be careful that this is only for 15 years again. So if you study for 40 years, 50 years, this will drop down dramatically. So this is only for 15 years. The reason we chose this is because fan coil units, you need to maintain it all the time. 15 years, basically you need to buy a new one. So, yeah. Yeah, a little bit sensitivity in order to prove that this study is valuable. So we did the same study in 4 other countries, in Lyon, in France, Hamburg, in Germany, Moscow, Russia, Madrid, comparing to London. So actually, the cost here in 3 of these countries are quite similar. So it's not that actually that sensitive to different countries. But you see a high cost here in Russia and a high cost in UK. This is because the local markets are different. And in UK, the labor costs are much more, and you need to train the installers and stuff. So this added cost increased a little bit here. But in general, in most of the European countries, we can conclude that it's not that high sensitive. So TAP is still a good, cost-effective solution, we can conclude. Yeah. In the end, I want to show an interesting example just for you to explore a little bit more how taps can be used in some special applications. So because we always say that taps are only used for new buildings, and you cannot really retrofit the building with the concept of taps. So here I introduce a new solution, and actually if you're a good engineer, you can always let the imagination flow in order to get the things you want. Yeah? So this is a historical building in Hamburg, and you can see this is made many years ago. It's a beam structure, and it has around 7-8 floors. And this building has been very old, and it has been not very actively used. But the building looks beautiful, and you can see here now it's mostly used as some storage place and not very active, and people want to use it more. And it's in a very nice neighborhood, but we are not allowed to change the facade of the building. So basically, you cannot put extra insulations of the external wall and the internal wall. And the ceilings look like this, so it has a lot of beams. This is an old classical way of construction building physics. And we are not allowed to drill, which means that it's hard to drill stuff on the wall, and they have nice bricks, so you cannot do too much on the internal wall, which means that radiators are not the best solutions because you still need to have some kind of interruptions to the envelope. So this is what we did. So these beams you can see here are the original ones. Then instead we cover it with steel mesh and put the taps on it. Then we cover it with concrete. Now we artificially turned it into a taps group. So this is how it's used in a retrofitting project. And of course this is limited to certain types of buildings and retrofitting. Yep. Thank you very much for the presentation, and if you want to visit us for the workshop, we can discuss more. Thank you.